Very good morning, students. So in last class, we have seen what are the different types of surveyings and the different instruments also. Now, today's class, we will see about different types of bearings. So commonly, we have two types of bearings. So that is first, whole circle bearing, WCB, whole circle bearing. And the second one, quadratic bearing. So now we will see what is whole circle bearing and quadratic bearing. So for suppose if we consider this is north and this is south. So in whole circle bearing, for suppose if the point lies here, O, A. So from north towards clockwise direction, if you measure an angle from north, so it indicates whole circle bearing. So from north, we have to consider. So here, this is the first coordinate and this is second coordinate, and here it is third coordinate and fourth coordinate, where first coordinate lies between 0 to 90, 90 to 180, 180 to 270, and 270 to 360 in fourth coordinate. So for suppose, let us consider bearing is 130 degrees. So it should be in between 90 to 180. So here from north, it will be 130 degrees. So this is how we will measure whole circle bearing. So the whole circle bearing will be in the range from 0 to 360 degrees for one circle or one cycle. So in same manner, if we consider quadratic bearing, so quadratic bearing, so this is east and this is west. So the quadratic bearing should be measured either by north or by south. So we have to consider only reference as north or south. For suppose if the theta lies in first coordinate, so suppose here theta is equal to 30 degrees. So it can be represented as north 60 degrees east, north 60 degrees east. And if the coordinate is in the third coordinate, the line is in third coordinate, the angle is 45 degrees, then it can be represented as south 45 degrees west, south 45 degrees west. So here we have to take north or south as the reference. If it is in second coordinate, then we can take as, let us consider it is an angle as theta south, theta east. So if it is in west coordinate, then north, theta, west. So this is about whole circle bearing and quadratic bearing. For suppose if the angle is, if the theta is 130 degrees, whole circle bearing, so north, theta is 130, 120 degrees, theta equal to 120 degrees. So it is whole circle bearing. So we can convert the whole circle bearing into quadratic bearing. So here from north to east, it will be 90 degrees. So since the angle is 120 degrees, the remaining part will be 30 degrees. Then it can be represented as in quadratic bearing south. So here it will be 60 degrees. Then south 60 degrees east. South 60 degrees east. So similarly, vice versa, we can convert whole circle bearing into quadratic bearing. So this is about whole circle bearing and quadratic bearing. So we can convert whole circle bearing into quadratic bearing as well as quadratic bearing into whole circle bearing. So next we will see in terms of formulas, if the whole circle bearing, sorry, if the whole circle bearing is in first coordinate, that is from 0 to 90 degrees, 0 to 90 degrees. So converting into quadratic bearing, it will be equal to whole circle bearing only because it is in first coordinate. But the coordinate will be in northeast direction. Northeast direction. Whereas if the theta lies between 90 to 180, 90 to 180, then quadratic bearing will be equal to 180 minus whole circle bearing. 180 minus whole circle bearing. The direction will be towards southeast. Southeast. So if the theta lies between 180 to 270, then quadratic bearing is equal to whole circle bearing minus 180. Whole circle bearing minus 180. The direction will be southwest. The angle is in between 270 to 360 degrees. 270 to 360 degrees. Then quadratic bearing is equal to 360 minus whole circle bearing. So the direction will be towards northwest. So this is how we can convert bearings from one system to the other system. So I hope you have understand what is meant by quadratic bearing and whole circle bearing and also conversion. Next we will see about what is meant by fore bearing and back bearing. What is meant by fore bearing and back bearing. Fore bearing and back bearing. So for suppose if we consider two stations A and B, here A, this is true north, and this is B. So here also north. So fore bearing is nothing but measuring an angle considering north as the reference and citing B. So here this theta will be called as fore bearing. And back bearing is the back bearing of AB will be also by taking north as reference and citing A towards clockwise direction. Towards clockwise direction. So the relation between forebearing and back bearing can be written as back bearing will be equal to forebearing plus or minus 180. Forebearing plus or minus 180. So I will tell when it will be plus and when it will be minus. So if the theta here is less than, if the theta is less than 180, if the theta is less than 180, then it will be positive. Then back bearing will be equal to forebearing plus 180. Forebearing plus 180. If the theta is greater than 180, then back bearing is equal to theta minus, sorry, forebearing minus 180. Forebearing minus 180. Just we will see. So here in this diagram also we can observe. So if we proceed like this, if you extend the line AB, so then the angle from north, it will be theta. It will be theta. So the remaining angle being it is a straight line, it will be 180. It will be 180. So then the total angle at B. So if you consider total angle at B as pi, so pi will be equal to 180 plus theta. 180 plus theta, where theta will be equal to the forebearing. So it can be written as theta plus 180. So theta is forebearing. So, and if the theta is greater than 180, then back bearing will be equal to forebearing minus 180. So this is the relation between forebearing and back bearing. So this concept will be useful in solving the problems. Thank you. We will see problems in the next class.